So hello everyone. This is the BTG for Kubernetes, Kuryr Kubernetes Resource Management. We are going to start with the discussion with what is already there, and a follow up with the session we already have like a couple of weeks ago. This there in the Etherpad. Just want to remind you that there is already a blueprint that maybe we need to review and slightly modify it, as well as a dev ref that I will modify accordingly to this discussion after we have some agreement about the next actions and what we want to target.
Right. I guess that we should, if Irena or Ilia or I have some points about the blueprint, because I see Irena is set as approver, but that it says the direction needs approval. So we'll need to approve it as well, probably. But I guess that it's better if we go through the Etherpad, and so continue, Luis.
Yeah, I mean, I just use that blueprint to have like all the patches linked together.
Right.
We will need to update it later on, and those are the 5 patches so far regarding one of the resource management handlers that we have. This one was about ports creation and deletion. So maybe I can briefly resume or summarize what we have already done. Those patches are waiting. Those patches are waiting for review, and as we were discussing in the previous section, in the previous meeting, this approach is not only to try to speed up some pod or container creation, deletion, or actions by trying to minimize the amount of interaction with Neutron. And it's not only,
which is always a good thing.
Yeah. And it's not only targeting ports, but also maybe in the future other Neutron resources like perhaps subnets or load balancers, depend on what we think we can improve. But the first target was to.
Well, the thing about subnets is that, if I remember correctly, if our new driver that we were discussing yesterday in the tenancy session, if we were to use subnet pools, when you delete the subnet, then that is like automatically returned to the pool, I think. So I think that part we would have already covered.
Yes, and it's not that critical as the port creation, and that's not that important during the port or container creation. So the idea here is to try to not having to create a port every time we create a container or a pod for Kubernetes, but trying to have like a pool of already ready ports to be used by those ports. And also the idea is that when the container or the pod gets deleted, we don't need to delete that port, but try to reuse it for the future so that we skip some Neutron calls, as well as we don't need to create and delete that many ports.
Right.
There are 2 different approaches here because it's not the same for bare metal and for nested environment cases. For the bare metal, we have already a discussion that maybe just having some modifications to the controller is not going to be enough. Most probably we will need some kind of pool of best devices for the CNI side.
Yeah, otherwise we pay the price of the activation dance, as I like to call it, which means when we are not reusing the VS devices, even if we reuse the port, we need to create the VS pair and then add it to open vSwitch, which triggers the process between OVS agent and Neutron to set the status active. Until that happens, we cannot return control to the kubelet. So yeah, well, I guess that you will show the result of how it is in bare metal and nested, right?
Yeah, maybe if you want, you can show right now for the current results for the bare metal.
Okay. So it's this one here, right?
Yes, here I tried two different cases. One of them was where you basically create containers sequentially, like one after another, and then just measure the time from the first trigger of the of creating one container till all of them are running. And the blue line here in the top one, it's when the normal approach, the currently upstream version. And this other two is by using the first optimization, only considering the controller side, where we basically have for the red line is a pool of up to 20 ports already created. And the orange, I think it is up to 60 ports. And we can see that, I mean, at the beginning, there is not that much different, but as
how do you measure when the port is running? Is it like you are watching for the status running?
Yes.
Okay.
Yes, a script. Like I check every second if all the containers are in run.
Okay. Okay. Yeah, I know. I thought maybe you made some Python script that watches,
Yes.
like with the controller.
This is a script.
So on the vertical axis, it is amount of pods, and on the right hand side is the time.
No, the y-axis is the second, the time, and the x-axis is the number of ports of containers. Actually, yeah.
Okay. So it would be interesting to see, like, if with the 60 member pool, I think it would be interesting to try to start like 80 containers to see if it also experiences the same degradation as we see with pool 20 when we go over 30 containers or so.
Yeah, I can explain what's happening here. I think for the red, for the blue line, of course, the more ports we need to create, the time is increasing.
Right.
For the red line, what it happened is that we have a maximum for both the red and the orange line of 20 and 60, but there is a minimum of 10 ports. So whenever the number of ports remaining in the pool is below that number, which I set to 10, it's configurable, then you create new ports. And what happened here is like, first, there is already some ports in the pool. So for the
were they full, the pools, or not?
No, I mean, they are created at the first time a container arrives or a container creation happen. If there is not enough ports in the pool, we create until the minimum, and then every time then we check if we go either over or below the minimum to create more or less.
Right.
So what happened in the bottom image at the beginning for the 5 parallel containers is like there is already ports there, so we don't need to create more. But when we are in, you can see this peak for the red line.
Yeah.
When there is 10, what it happened there is that we went below 10 ports. So besides creating the container and which was assigned to a normal port, the Neutron server was actually also busy by handling the new ports creations that happen in a pool.
And was that a batch creation or just several creations?
It's batch creation. Yeah.
Okay.
There is another parameter in the patches that basically has like the batch size that I set it to. I think it was 5, but we can modify it. Yes.
Cool.
And then for the 20, what we see is that they already have enough ports in the pool, so we don't need to create. And then over 20, of course, for the red line, we don't have enough ports in the pool, so we always need to create them. And that's why it basically gets closer to the blue line.
Well, I would have expected the behavior to be that when it gets to 20, it exhausts the pool. So it resizes it to 20 again, and the ports that are already allocated are considered like out of the pool, right? Or you consider the ports that have been associated to pods to still count for the pool size, or?
No, we only consider the available ports ready to be used. So what happens is that if the queue is 20, then those 20 pods came into the queue, into the pool, pick those 20 ports, but then we need to create another at least 10 to have the minimum size. But the Neutron server gets some, I mean, it's the bottleneck and so many requests because we still have to update the ports to have the new name as well as waiting for the state for the active, and that's why there is so much interference there.
Okay.
And actually, I reached some points, especially for 40 and 50, where for the normal upstream case, sometimes it will hang forever. It's like Neutron even lost some messages or something due to the high load.
Okay. What was this running on that bare metal server that you allocated?
Yeah, this
okay.
One of these bigger VMs, yes.
So
64 core.
Then you made runs for 10, 20, 30, 40, and 50, and nodes, like separate runs, like one after the other, maybe?
For the plot on the bottom?
Yeah.
No, that's just basically a replica controller. So I said that I want 40 replicas and 50 replicas. Yeah.
Okay, very well. If anybody else has other questions about this, like feel free. So the first one, the one on the top, is with just having a lot of YML files or a YML file describing that amount of pods.
Yes.
And the bottom one is using the replication controller, right?
And actually, the script is happening kind of, it first does the one in the top and then continues with the one in the bottom. So that's why where we can see that for 5, 10, and 20 in the bottom is slightly faster than for 5, 10, and 20 in the top, even though it's kind of the same creation.
Okay.
This may be also useful to see the impact of, let's say, creation and deletion, and then once more creation and deletion to see if there is some impact when the pool should be, when consumed, ports should be returned and then acquired another time. Did you run some test like this when you first create a bunch of ports and delete and then create new ones?
Yeah, that would be nice.
Actually, in this kind of, I didn't get the time or measure the time to delete the ports, but actually the termination of the pods was faster with the ports pool approach. And actually in these runs that we see here, this happened one after another. So after for instance, after the 10 parallel ports were created, then I delete them, they return to the pool, and then the 21.
So between each number, like between 10, 20, 30, 40, and 50, you are modifying the replica amount to 0, then to put it to 20, then to 0, then put it to 30?
Basically, what I do is just kill the replica or stop the replica and create a new one. But when I stop the replica, the ports that were used by that replica controllers, the replica pods, they are put it back into the queue if the queue is not big enough. I mean, sometimes I need to delete the ports, or the ports are deleted, or sometimes they are put it back into the queue, into the pool.
Okay. So just to make sure I understand it. So let's say that you just got 20 replicas. So what you would do is you would go and kill them, and then apart from that, resize the controller to 30?
Yeah, basically what I do is I create, let's say, one replica controller with 5 replicas. Then when all of them are running, I basically stop that replica controller, and wait like, I don't know, 20, half a minute, and then create a new replica controller, but instead of with 5 replicas, with 10 replicas. It's not like that I'm modifying the replicas, I'm creating again 20 at the same time, not just.
Right.
So from 5 to 10, it goes 5, then delete 5, and then create 10. It's not that we go from 5 and just create 5 more to get to arrive to 10.
Okay. All right. So we go back. Does anybody have more questions about the bare metal graphs? All right. So let's go back here so you can go over the nested points that you put.
Yeah. I mean, the nested actually doesn't really need the CNI side as the ports are, when they become subports, they are already attached to the VM, so they are already inactive. That gave us a lot of advantage. And as we are going to see on the plots, the performance is much better. The mechanism is pretty much the same. We have a pool of ports that has a certain amount of available ports between a minimum and a maximum that we define, so shoot results. And they are also, there is a different pool per trunk port and per channel and per security group. And basically what we do is when we clean up the port, meaning that when we kill the container, we basically put that port into a cleanable pool, and the resort or the port pool handler, basically what it does is reapply the security group and put it back into the disposable or ready to use pool of ports.
All right.
And I mean, we skip the pooling here, as well as we actually save more Neutron costs, as we don't need to do port creation, but we also don't need to do the port attach, the sub-port attach, as well as the inherent update.
Right, of course. Well, you're doing the update to put the name of the pod, right, on both cases?
Yes, but the thing is that the sub-port attach actually already has an update inside, so then we change 3 costs by just 1. So
okay, that's nice, really nice. So,
and the results are actually more.
It's in the
more linear. It's better if you go down to the nested.
Yeah. Oh, that looks beautiful.
Yeah, that's really nice, and it's. I mean, there is less weird behavior. We see that, of course, as we increase in the number of ports for the blue line, the upstream one, it gets slower and slower. Though I must say that I got kind of a weird behavior here, meaning that creating ports for nested environment, when you have a lot of them in parallel, is actually faster than doing it in the bare metal case, which was not expected.
Well, I think it's reasonable, right? Because in the bare metal case, like there's a lot of more communication going between Neutron and the OBS agent, and in support, I think it just gets the agent just gets a notification that it should add the support, and I think that then it doesn't do as many requests, but don't quote me on that. I may be wrong.
Yeah, I think maybe the agent, it's here having a.
If you don't mind, I'm gonna be checking this. So what we have is 150 seconds. Okay, so it's like 100 something for 50, right? Where do we have the result?
Especially for the sequential one.
60. What are these numbers?
Those are different. I run these different times.
Okay, you run it several times. Okay, and the average. Okay,
5 times.
So the average is 114. And for this, it is.
But for the upstream case, actually, for the
73. Yeah, that's
for the pool of ports, it's actually much better. But that was actually what I expected. That for the nested port.
Right. So for the upstream it's 251, and for nested. Wow, this I wouldn't have expected to be so much slower in nested. Yeah, it's almost double.
Well, that's
Interesting. Well, so for the nested, it's really a huge gain.
yes. I mean, we can see also that there is not that much difference for the pool 20 and 60 when the number of ports that you need to create is below 20, as you can see in the upper figure.
Sure.
So that's pretty much the same for both of them. And the bigger you go, the bigger the difference. And in the bottom figure, when we create the replica controllers, of course, when we reach the point of 20 containers, meaning 20 ports, for the red line, as the amount of ports in the pool is not enough, we still need to create, and then
Right.
that's why
That
the red
is-
line starts increasing.
Yeah, until 40 there is one extra. You put every time it's 5? Like the batch creation is 5 ports?
Yes, but it might happen that
Okay.
you check, it's every time it's 5, but when you check, for instance, let's imagine that the minimum is 10, and you just have one port, then you create 9. So you at least go to the minimum, and let's imagine that you have, if the minimum is 10 and you are you have 8 ports, then you create 5 more, or the amount that you have in the batch. But at least you need to reach the minimum.
Okay.
What I found at the beginning, and that's why I kind of include some kind of logs in the code, is that it might happen with this replica controller that you receive all the calls at the same time, and then you create more ports than you need. So I put some kind of time-based log at the code so that we don't create or we don't update the pool for creating new ports every second, or we wait at least 5 seconds. Otherwise, the Neutron server doesn't actually have enough time to create those ports.
Right. No, I was wondering if instead of doing that, we could instead of doing the locking, I mean, we could annotate the node object itself and to keep the pools there instead of using third-party resources. I don't even know if it's possible if node is not a protected resource for the API, but I think that would allow us to see, like, if you're using the replication control and you get a parallel request, you would be able to see that something already started creating, like replenishing the pool.
Yeah, maybe I can put some extra information into the pool, because the problem is that, I mean, the creation actions take some time, and then the next time you check, the ports are not yet there, and then you believe that there is not enough ports, and that's why you trigger yet another creation action.
Right. So what I was thinking was something in the lines of, so right now, this is difficult because right now you get a green thread, sort of an actor per self-link, right? We use the self-link to decide so that if a pod has more actions, pending, they all get queued on the same actor. I wonder if it would make sense to queue them also in respect to the node that they are using, or the trunk port that they are using in case of nested, so that you would avoid the locking. Well, no, because the problem then would be that if you would have enough members of the pool, you would just be waiting needlessly, I suppose. Yeah, you would not be as parallel as you could.
Yeah, I was thinking about having like some kind of random interval figure that, yes, kind of like that, but I was not sure. What I'm doing right now is just waiting like you have a parameterizable time to decide how frequently you want to update the pool. It's like you don't want to update the pool below 5 seconds or something like that, because still
Right.
you will be able to create that many ports, because Neutron server we need to create them anyway, so it doesn't really matter.
Yeah. No, I'm trying to think about some alternatives for that, because in general locking makes me uneasy.
Yeah, I mean it's actually not really locking, but it's like if one thread tries to update the pool and it was kind of marked that it was updated a few seconds ago, then you just do nothing. I mean, you will have another call.
Yeah, no. What I'm wondering is whether you really need to do nothing and wait, or you could instead just say, okay, we failed the operation and we wait for the event to come up again. I don't have a good solution for that. So what you're doing now is you're waiting on the value to change?
No, I mean, I'm not waiting actually. It's like I just check, did I update the pool during the last, let's say, 5 seconds?
Right.
If not, then I check if I need to update it or not. And if I update it during the last 5 seconds, I just do nothing. Just skip this call as I will receive more for other ports. So
okay.
It doesn't really, as is for the pool, is not for the port, for the container itself. The container itself has already its port. So it's just a matter of filling before or after the pool.
I'm not entirely sure I got that. So
yeah, we can.
Okay, let's let's say
the action item.
Let's say that I have the pool has one port over the minimum. I get a request, so there is a pod creation.
Mm-hmm.
I take that member from the pool. I see that the pool is going under the minimum, and I send. Well, I start the process of replenishing the pool, right? I made a batch creation. I make a batch creation to Neutron and so on. If another request comes immediately after that for a port, for a pod creation, for a pod addition, in fact, the flow that you're saying that will happen is that it will see that the pool is being replenished, and then what will it do? Like, it will not continue checking if the pool needs to be replenished, but will it just create a port without going through the pool, or what will it do?
No, I mean, this is handled by a different handler, so it's kind of in parallel to the port creation. So whenever there is a container creation, it will just take some port from the pool, and in parallel there is a new thread that basically is just checking if the pool needs to be republished.
Sure. No, but what I'm asking is, in the case when the pool is empty, in the VIF handler, what do you do?
Yeah, I mean, I go to the function that try to republish this, and then if as I'm not sure if it's really empty or the action to refill it was already triggered,
right?
I just check what was the last kind of timestamp when I did an action, and if this last timestamp was within the last, let's say, 5 seconds, then I do just nothing. It's not that I wait; I just skip this call. But if it was farther away in the past, then I just continue and try to republish create new ports for this pool.
So when the pod gets its port to proceed with the pod creation?
Sorry?
Like you depend. If I understand your question, Irene, is like, if you skip the port, the VIF handling, in this case, the port, the pool is being replenished. The question is, like, when are you gonna get another event for the pod so that it finds a port? Is that right?
Yes, yes.
Yeah, I had the same question in mind. So yeah.
Every time you create a new, or you have a new container into the system, a new pod into the system, you will receive a new call to check the status of the pool.
Sure. No. So the question is, you say that if a pod addition comes like less than 5 minutes, less than 5 seconds into the pool replenishment being started, you will just not do anything from the controller about that pod. So like the event will be ignored. So the question about this is, then CNI will keep watching for the beef information to appear eventually.
No.
And our question is like, when will the controller finally put a beef for this pod?
But the CNI doesn't have anything here to be, because I have like a pool of ports ready to be used, and the container is just taking one from that pool. And this other process just.
No, the question is when your pool is empty.
Hi, Ilya.
Yeah, hi. I've been here. I've been working here for quite a while. Yeah.
Yeah. I didn't see. Yeah, go ahead, Ilya, please.
No, I finished my question. I think.
Okay. Yeah. So when the
I just wonder, maybe it's just the event is resubmitted with.
Yeah, resource not ready.
Resource not ready. Yeah.
Yeah, absolutely.
Right. So you're raising resource not ready exception, I suppose.
Yeah, I would expect that, but I'm not sure if Lewis is doing that.
No, because the thing is that you are not creating ports one by one. So whenever you don't really need to check this even for every new port, every new container that arrives into the system. It doesn't really matter if you skip one call.
I'm not sure if I understand you right. So let's say we have two handlers, right? So one handler is managing the pool, and the other handler is only for the ports, for VIFs, right? So it takes the port from the pool and adds VIF annotation, right?
Yeah.
So what happens with this second handler? Not the one that manages the pool, but the one that annotates the VIF. So,
but I mean, the one that annotates the VIF, it's basically the same as we had before. The only difference is that the VIF that it takes is one from the pool instead of.
Sure, but when there is no VIF from the pool.
So how do we wait for?
Okay. Now I got your question. If there is no beef into the pool, basically you do the same as you have before. It's just you just create a new port for your container.
Right. Yeah. So there were two options: to raise resource not ready, or to create one separately.
I can say I like it very much because we have like the same functionality of creating ports in two different places, and this kind of ugly.
Yeah, I would prefer if we would just raise resource not ready rather than making an extra Neutron call.
Simplify the code and remove all the Neutron interaction from the VIF handler.
I agree with that.
Okay. Because basically what I did right now is that when there is no port, I basically call or use the previous.
Sure, of course. Like
it was there.
Like it makes sense.
It would just simplify the logic. So you just raise the resource not ready exception because that's exactly what this exception was created for. Exactly for cases like this. And you get retry, and you'll retry, and this retry is quite cheap.
Yeah, but then you need to wait for the 10 ports or whatever you specify in the bool creation to be created instead of just one. So it will slow down the container creation.
I don't think it will slow it down significantly because you will be bothering Neutron less. So that's something that definitely needs to be measured, and I think it's very easy to measure, Luis. It just about that when you don't find a port, you just raise resource ready directly there, and it will just work. That's the only line that needs to be added, and I would really be interested into seeing measurements with that.
Okay, I can do that.
So can let's put it as an action item. Measure performance when raising resource not ready, when there's no ports in the pool in the beef handler. The other thing, since Ilya is here, and I'm not sure if he heard it before, I mentioned about keeping some info about the pool in the node object.
Yeah, I heard that.
Yeah, I wonder, do you know if that's possible, or you think it makes sense or not?
I think it would lead us to. You mean in the node annotation, right?
Yeah, annotate the node, not for all the changes, but
Yeah, I
to
think it
keep some
would
sort of
lead
information.
to too many interactions with Kubernetes.
Well, my point was, if the choice is between third-party resources, a node object, I think it's probably better to do it in the node object.
Well, you see, I had some idea about this. I'm just how to manage this, how to store this
pool?
information. Yeah.
Okay,
So basically, I was
please share.
thinking, I was thinking that we can follow our stateless approach a little bit more, and not rely on storing this information in the controller, but rather just caching it. So
Where?
like,
You mean in disk or?
yeah, so let's say we create ports on the Neutron side, and we have something we can later look them up with list ports. So either it's well, device owners certainly not an option right now.
No.
But we probably can use tags for that.
Well, let's think about this a moment. Device owner is not an option, but we will still have the ID of the machine where they are, right?
ID of the machine
if they are
is,
bound?
you mean the node ID?
Yeah.
I'm not sure if it's effective key for the lookup. So I was thinking about tags.
Do you mind if I put this as an action item?
Yes, sure.
Okay. Check if.
Well, anyway, when you look up by node ID, you will get other ports as well, not just the nested ports in Lewis case.
Sure.
You could have not just Kuryr, but also Nova running on the same node.
Sure, well, but the alternative is to use tags, and Neutron, we know that the tags are not indexed in any way. Or is there a third alternative?
Well, I'm not sure if we can if we want to use tags, but I'm just saying that some way to get the list of our ports by like Neutron list ports, and we actually need it anyway for the cleanup. So we need this facility like anyway.
You mean a facility for listing just our ports?
Yeah, for listing ports that belong to Kuryr.
Okay.
So it's quite easy with device owner. So I would actually try to push Neutron community to revert this crazy change about device owner. Because
the PTL is on your side. We can make pressure from all the sides.
Yeah, so we can get this, because well, it actually makes sense. It's really makes sense, I think. So let's say it's like either tags or device owner. But anyway, we have this facility, right?
Yeah,
I think, by the way, with support, it also should work because we know exactly where this support is hosted, and based on the hosting VM,
Well, with
filter.
supports, it's even easier because we
that
yes.
is a very interesting point, because then we can assume that all the supports belong to us.
Exactly.
Absolutely.
Mm-hmm.
We just know the trunk port, and we can like find all the trunk ports because we know all the nodes, and we know trunk ports because we need to know them to create supports, right? So
yeah, it's actually part of configuration.
Yeah, we have this anyway, and we don't need to know anything about supports because listing the trunk port gives you all the support information in one call. But anyway, that's just like details. So the idea was that if we have this lookup facility, and we pretty much do have this, we can use query Neutron to get this list and cache the result. So we don't rely on the that information being stored in on the controller side, but we cache it, and this call is not. It's not like this call should be like costly, because well, list ports is well kind of fast call. So
well, but what we're saying here, like the underlying statement is, if you say that listing by device owner, unless we make a device owner just for pull, which is also a possibility that we say Kuryr pulled. Otherwise, it means that all the Kuryr ports are pulled, right?
Yeah.
Okay, so it's either we make
no. I mean, we don't expect we can actually get to the point where we have pulled ports and non-pulled ports at the same time.
Now I'm in the mood to eat pulled pork. Sorry, I'm still in the barbecue mind of Atlanta. So, but like I think that we should have probably some non-pulled ports, but in that case, it means that we should have probably different device ID, right? Device owner, sorry.
On tags.
We can use tags in this case because they are not used for lookup, but just
we'll still get them when we do the list. We still get all the information, including the tags, right?
Yeah. So
then it's fine. So I'll remove.
If we reboot the Kuryr controller, how do we know what ports belong to us?
Well, by the device owner.
When we have the device owner, okay.
So
well, for the look, the parent port. I didn't check about the trunk port. I think the trunk port also belongs to us. So for the
trunk ports, I think it's exactly the trunk port that has our device owner. So
exactly. The trunk port does have our device owner. It's only the supports that get
Okay.
and we don't care about supports.
filtered out. Yeah, but the problem is when we do the list ports by device owner, of course, those will already be
those
filtered out. Yeah, that's good. Okay, so let me put it like
that
this.
the trunk ports, because when you list the ports, you will know it's a trunk port. So you can actually look up supports for this trunk. It shouldn't be a problem at all. Or maybe actually, I'm not sure if it's in the node list or trunk like show, right? So where all the supports are listed along with the trunk port. I'm just not sure if it's show trunk or show port for the trunk port.
I can check that.
Yeah. So we have this list of all the supports that belong to
it is there, yeah. Supports of those.
We don't actually need to look for the supports itself.
Well, you need to add the supports to the pool, to well.
Yes, but doesn't mean that you'll need to look up them specifically. You just look up the trunk. But it does make
right. Well, no. When you look up the trunk, when you do a list of trunks, you get already the list of supports. I thought that was an extra operation, like that you have to make a show. A show that you need to get supports passing trunk ID.
Yes, probably, but I'd say that it's a small price. It's a small price to pay. So I'm not saying that we'll be doing this lookup for each call, right? So
only every time we lose the cache.
Yes, and cache in case of the single-headed controller, so not active-active, right? There is no reason to invalidate the cache because, well, we have the full control over it. And when we get to active-active, at some point, there are also ways to manage this cache, to partition it it can be partitioned between the nodes based on the hash ID of the request. But we'll get to this later.
Very well.
Later, I mean not today.
Yeah. All right, we have 7 minutes. What else do we have? I think the action items are quite good. I don't think we need 3 anymore, though, right? Like it would be nice, but if we use the listing in the trunks,
yeah, it seems not required.
Yeah.
Let's keep it in case.
Should we have it as action item? Because
it's a low priority one. Like if the Neutron people want to do this out of the kindness of their hearts.
No, I mean this cache-based approach instead of storing it anywhere.
No, yeah, I think it makes sense because the information is there. We don't need to add stuff for it.
So
I think it makes sense.
Luis, will you update those patches with this approach or?
Yeah, I'm happy to work on that.
Okay.
Information.
And please also update the devref with the decided approach.
Let me put that code modify import our for is managed like I know the wording is terrible. And the file.
And for caching, we have Oslo cache that would also be backed by something like memcached or just stored in memory. So for cache, I'd prefer if we use Oslo cache.
Okay, let me keep it cached with Oslo cache. That's
And
nice
it's
into
pretty
the
nice
recording.
to use. You just annotate
Okay,
the function.
Never seen it. That's cool.
You just
So-
add a wrap. Well,
Yeah, it's
this-
a typical thing that you make a decorator for a function, and then it keeps it in memory, and it's transparent to the color, right?
Yeah, it's very nice.
Does it have some expiration configs or?
Yeah, it has
That's
TTL.
That's perfect. That's perfect. Cool.
I have additional point, maybe just to raise, not mandatory have the answer right now, is more about the settings per pool. How it should be
Right.
advised to the deployer, what minimum value to set, what size to set. It probably should be driven by the expected amount of pods to be deployed in the cluster. So
Yeah, it should be a recommendation depending on what is the like the expected amount of replicas,
Active
like for the burst. It's for
Mhm.
it's for burst, I would
not
say.
not really for the burst. Well, yes, for the maximum number of concurrent activating ports.
Yeah.
Right. So this is the typical burst scenario of university students get at 9. They all start their pods, and they take down the system. So that's the use case here.
Well, in this case, it's pretty much the average number of active ports. It's not really the burst.
Yeah, so this goes for the pool size, but there are more settings. If I remember correctly, it's some minimal amount that once the pool gets to this number of ports, more are going to be allocated, right, Luis?
Yeah, we have right now we define a minimum and a maximum, and the pool will vary between those numbers.
Okay, so I put an action item to document.
Do we actually need to limit the size of the pool?
No, we don't. We could have a setting 0. But
I'd say we just don't add this option. I don't think there is any reason to have a limit for the pool size. In case without the pool, we don't limit this, and I don't think you should. Anyway,
I think actually pool size is limited by the quota that Neutron has.
Yeah, that's my point.
Well, there's two implicit limits. One is the quota, and the other is how big your subnet is. So.
But it's not only that. I mean, we need to have different pools for different tenants, for different security groups, for different servers. So we don't want to have, I don't know, it could be too many ports. Yes, I mean, it's nice to have a limit.
I would allow users to set a limit. Whether we want it enabled by default or not, that's a different question, and I'm siding more with Irena and Ilya.
I'm not sure what you're saying, Luis. I mean, when you have we have this minimum limit, which makes sense. Yeah, it's absolutely right. So when the user creates those ports, why would, and as long as there are enough resources on the Neutron side, I don't think we need to add some limitations, because, well, it kind of make things weird when you like.
Right now we are not modifying the Kubernetes scheduler at all, and it may happen, for instance, that all the ports or the containers that are removed are on the same server. So you end up with a queue that you have 20 ports or 100 ports in just one server, and the other ones are empty, and then you are going to always send the traffic to those, right?
Well, I would expect that after some time we just free those pods.
Okay, so you want like a timeout for the pool.
Yeah. So you have this you ramp up this pool right? So at some point, the students go home, like after their stuff.
Work day, yeah.
Yeah, and you don't need to keep this pool until the morning. You just keep it for a couple of hours, anticipating other bursts. And if
Okay,
the system stays calm, you just free this pool and just delete those ports.
Sure.
No,
The behavior that you mentioned makes sense, but how would you actually do that? Like before we have the cleanup, let's say handler or tasks.
But actually, I mean, if you remove the ports before you are going to have the burst, then you are basically losing the advantage of this. It's the other way around. I mean,
No. You have this minimum pool size for the burst.
Yeah, the TTL only applies to those over the minimum, I suppose.
Yeah.
Okay.
You don't free up all the ports from the pool. You free up until the minimum limit. So that's what's the point of this minimum limit.
But why would you have? I mean, if you already have the minimum covering for the possible bars, why you want to have the possibility of have 10 times the minimum in one of the queues? It's just, I mean, you don't need that. Why you want to keep it? It's resources that you are just wasting. And if there is some Neutron agent restart or something, that's going to take a lot of time, or some failover or something like that.
I'm not sure I understand what you're saying.
Sure.
So you have this minimum pool size. So what it's saying is that at any point of time, you have like 10 or 20 or 50 or 100 ports ready for the burst, right? So that's what the minimum pool size is, if I understand correctly. So Kuryr guarantees that you have these buffer ports, and if you have if it's like 10 and at some point there are like 50 ports in the pool which are ready for use, why do we need more than 10? We have we have set this limit because we know that at any point of time our burst is about 10.
Okay, so you want to limit to 10. It's like 10 is minimum and maximum.
No, it's not maximum. It's the minimum. It's this buffer to smooth out the burst.
But what Ilya is proposing is also adaptable in the case that you are going beyond expectation. Let's say
it's not minimum. It's target. Let's name it not minimum but target.
So if the activity in the cluster increases a lot, you will not be aggressively deleting ports because there will be a configurable TTL. So while the activity keeps strong, you're not deleting stuff. Even if some pods get deleted, they still go to the pool, which in that case, let's say it's 300 big. But once the TTLs start to expire, if the activity is dying down, you would be shrinking as well the pool. Did I get that right?
Shrinking, I would propose like halving the pool size each time. So
sure.
it would,
so you can do batched operations as well.
Yeah. And what I mean is not that will be like you have created 300 ports at time 0. Then you have them freed at some point, and you won't delete all those 200 ports at the same time, but you'll first TTL delete like 100.
When the TTL of 100 of them expire, what you say is that you would just delete 50 and leave the other ones for the next time?
Yeah.
Okay.
So this I'd like to draw this. It's like the. So it's
Okay,
not like a full drop from 300 to 0
right,
to
right.
the target, but it should be smooth and slow.
Okay. The idea sounds quite good to me. I would like to have that in a blueprint. I know you're not very friend of blueprints, but
I like them. I just don't like to write them.
I know, I know. Let me put as an action item, make blueprints or blueprint for.
It's actually part of this cache-based approach.
Yeah.
So you can put it there, I think.
Cache-based approach. I'll put reference to 4 and I can keep it in another line because otherwise that point is too big. All right, so we are 6 minutes over time, so we have 9 minutes until the next session. If there are more questions or anything, we can bring them up on the mailing list. Thank you all for joining this session. I'm looking forward to start the next one. I'm stopping.